How's it going, everybody? It's Mr. Hobbig. We're going to learn about some triangles today. We're going to talk about isosceles triangles and equilateral triangles. Talked a little bit about it in the last one, but we're really going to get into it this time. Okay, so let's get started. Hopefully, you have your notes. Okay, the congruent sides of an isosceles triangle are called the legs. Okay, the vertex angle is the angle that's formed by the legs. The opposite side, the vertex angle, is called the base. And the base angles are the two angles on the ends of the base. So let's label it. Okay, so the legs are the congruent sides. So this one is a leg. This one is a leg. Congruent, remember that means the sides are the same length. Okay, and the angle that's made by these two legs, this angle 3 here, is the vertex angle. Okay, and angle 1 and angle 2, these are the base angles. Ugh, 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 ugh. All right, this is the base angle. And then this side right here is called the base. Okay. So your congruent sides are the legs. This side is the base. Base is touching both of the base angles. The legs make the vertex angle. All right. Isosceles triangles are so cool. Oh my gosh. So many theorems. Okay, here we go. So if two sides of a triangle are congruent, then two angles are congruent. Okay, so what does this mean? If these two sides are congruent, then that means angle B is congruent to angle C. And these are the base angles. Okay. So if the two sides of a triangle are congruent, that makes it an isosceles triangle. Then there's two congruent angles. So something that happens with triangles is that the angles determine how big the side is. So a bigger angle, so like this angle B right here, is going to determine how big this opposite side is. If this angle was bigger, then the side would, oh, that's not very good. If this angle was bigger, then the side would be bigger, right? The side would be bigger. You see that? That's going to be kind of a common thing. So the sooner you can figure that out. So in this case, because the angles are congruent to each other, or because the sides are congruent, that means the angles are congruent. And this is just the converse of that. So if you have two congruent angles of a triangle, two angles are congruent, then that means that you have two congruent sides. And what does it mean if you have two congruent sides on a triangle? That means it's an isosceles triangle. Okay, so isosceles triangles, not only do they have two congruent sides, but they got two congruent angles. The base angles are congruent on an isosceles triangle. So if I know one of them, I can find out everything. And we're going to do that right now. We're going to find each angle measure. Okay, so if we know this is 38 degrees, then what's this one? How would we find that out? Well, what do we know about angles in a triangle? When you add them all together, it's 180 degrees. Always remember that. Add up all the angles of a triangle, it's 180 degrees. This one's 38 and this one's x, but I need to know what this one is. There's the geometry of it. There's the thing we just learned. Because we know our base angles are congruent, we know angle C is congruent to angle B. So angle C is also x degrees. So let's set up our triangle angle theorem. What was triangle angle theorem? All three angles added together equals 180 degrees. So here's one angle, two angles, the third angle. Added together, 180 degrees. Okay. This is going to come up a lot. So all three angles adds up to 180 degrees. Remember. All right, so we're going to combine like terms. Let's do the algebra. There's two x's. Try to do this algebra ahead of me so that you can check your algebra. I know some of you guys struggle with algebra. You really got to learn how to do algebra. So take these notes as another chance to practice. You have to practice to get good at math. Some people are just naturally good at math, but it comes for them. I promise. You can't just keep going to math, not practicing. All right. So that's what we ended up with. We subtracted the 38. Now we're going to divide by 2. And we get x is equal to 71 degrees. So 71 degrees, 71 degrees, 38 degrees. Plug it back in. Make sure it adds to 180 if you want. It's a good check. All right. Did it. Now let's come over here. I got two congruent sides. Hey, this is an isosceles triangle. That means my base angles are congruent, right? Well, which ones are my base angles? Well, they're opposite the base. This is the base, right? The base touches both the angles, so these are my base angles. That means they got to be congruent. So if they're congruent, they're equal. So I can say they're equal. X plus 30 equals 2x. Well, if 2x is the same as x and a 30, how much do you think x is? I wonder. Let's see. Subtract an x. Maybe that's easier. 30 is x. All right, we did it. We're done, right, guys? Nope. What's the problem actually asking? What's the measurement of angle S? Okay, so S is 2 times x. So 2 times 30. Or 30 plus 30. Because they're congruent, right? You could pick either one of them, actually. You're going to get 60 degrees. 60, 60. What's this one? What is it? Do you know it already? Do you know it already? It's 60. It's an equilateral triangle. Because equilateral triangles are actual angular triangles. If your triangle is an equilateral triangle, which means 3 congruent sides, then it's equal angular, which means angle A is congruent to angle B, which is congruent to angle C. And if they're all 3 congruent, then they all add up to 180 degrees. And 180 divided by 3 is 60 degrees. So all equilateral triangles have 60-degree interior angles, 60-degree angles. Every one of them is going to be 60 degrees. So, and if an equiangular triangle if a triangle is equiangular, then it's also an equilateral triangle. My sides are all congruent. Remember how I said angles make the side? Well, when the angles are congruent, it makes congruent sides. That's what happens. Okay, so let's find x. All right, well, I just kind of talked about this. 3x plus 15. Now, you could use triangle angle theorem and add 3x plus 15 three times to get 180 degrees. But if you're clever, you know that all the angles are 60 degrees, so this is actually 60 degrees. So if this angle is 60 degrees, I can say it's 60 degrees. Oh my gosh, I set up an equation. It's algebra again. Are you already completing your algebra in this problem? Do the algebra. It's 2 steps. What would you do first? Try to have it done before I get it done. That's why I'm going slow. Minus 15 from both sides. Do that to get rid of the 15. That's why I did it. You end up with 3x equals, boom, 45. What's x? We're going to divide by 3. That gets rid of this 3 here. $45 divided by 3 is 15. So that's x. Okay. We got an equiangular triangle. That means that all my sides are congruent. Equilateral triangles have congruent sides. How would I set up an equation to solve for t? Well, since the sides are congruent, I can say that they're equal. 4t minus, 8 is equal to 2t plus 1. We're in algebra again. Look at us. We stumbled into some algebra. Try to finish this before me. We're going to have a 3-stepper. A 3-stepper? I like to keep my variables positive when I can, so I'm going to subtract the lower coefficient. Why would I do that? Gets rid of this guy. Moves all my t's over to one side. 4 minus 2 is 2. This is gone. Left with that. Are you already done? It's pretty cool. Way to go, that guy that's already done. Good job, that girl that's already done. Get rid of these. There goes my 8. All I'm left is that 2t. What's it equal to? It's equal to 9. Oh no, we're going to end up with a fraction. Why? Divide by 2. Then you're left with t is equal to 9 halves. Or 4.5. Okay. Are we done? We sure are. It asks for t. If it asks for the side, though, I'd plug that 4.5 into there. You'd figure it out. All right, here we go. Here's a review problem. What's the measurement of angle A? Here's the exterior angle and the remote interior angles. Do you remember this theorem? Do you remember it? Basically, this angle plus this angle is equal to the exterior angle. The exterior angle is equal to the sum of the remote interior angles. That's the theorem. So the exterior angle, 124, is equal to the sum of the remote interior angles. Here's the remote interior angles. So it's going to be 10x minus 5 plus 8x plus 3. Once again, the theorem is, I'm just going to write it real quick. The exterior angle is equal to the sum of the remote interiors. I just substituted in this thing. Okay, so combine your like terms. This is algebra again. We're back. We're back, baby. This is all the geometry right here. Actually, this was the geometry. This little line. This little guy. All the rest of it's algebra. Combine your like terms. There's 18 x's here. Negative 5 plus 3 is minus 2. What'd you do next? Did you add 2 to both sides to get rid of that minus 2? I hope so. That's going to be 126. 126 divided by 18. Uh-oh. I can't do it in my head. So hard it is in my head. What is it like? 2 something? 6? No. 4? Maybe? No. 9? 7? Probably 7. So let's say it's 7. 7. Yeah, that's what it is. Anyways, we're dividing by 18. To get rid of that, 7 times 8, 6, 56, 5, 7, 12. Okay. Oh, get that. 7. All right, we did it. Did you say we did it? We didn't do it yet, you fool. We're doing the measurement of angle A. Here it is. It's 10, but instead of the x, I'm going to write what x is, which is 7. Minus 5. So it's 65 degrees. Do you already know what this one is? I wonder if you know. Can you just tell what that one is? I'm moving on. It was 59. That's the end of the notes. Let's move to the assignment. Go open your assignment, guys. Do you have it yet? Oh, hold on. I'm on it. I'm on it. Everyone relax. Pass the assignment out. Ooh, got a bit of a hefty guided practice today. Look at this. 6 problems? I'm spoiling you. Are you spoiled? Sometimes I don't know if I'm writing behind my head. So sorry if I did. Okay, the measurement of ECD. So here's ECD. ECD. That's going to be this angle. I like to kind of mark my angle with an arc and then just kind of call it X. I don't know. That's the one I'm looking for. Okay, how would I get up here? Well, any ideas? You know what's cool? These are vertical angles, so those are going to be congruent to each other. Got a couple of congruent line segments here. Maybe that means, now hear me out, that this is an isosceles triangle. So if this is an isosceles triangle, that means I have 2 congruent sides and 2 congruent base angles. So this is 31 and this is 31. So what's this one? Because that's X, right? Those are congruent to each other. What's this one? Well, we're going to use triangle angle sum theorem. So here we go. The X, because this is also X, right? X plus 31 plus 31 is equal to, how many degrees is all 3 of the angles in a triangle equal to again? I forgot. I didn't forget. It's actually 180 degrees. Combine your like terms. Combine your like terms. 31 and 31 is 62. What's x? How would I possibly know that? We'll subtract 62 from both sides. And that gets rid of that guy. And we're left with x is equal to, that's a good sign. Come over here, 108. How am I getting laggy? I'm like literally sitting at my computer. That's that one. Okay, next one. Hey, looks like we got a couple of congruent sides over here. That means we got a couple of congruent base angles right there. Hey, those are congruent. What does that mean? Is they're equal. Okay, so let's say they're equal. 5t minus 13 equals 3t plus 3. Okay. Here we go. So I need the measurement of angle x. That's this angle, right? Okay. So we're going to combine like terms. Or I'm sorry, move your x. Not combine like terms. Refocus, Phil. Mr. Hobwig. Okay, that cancels out. My dog's making crazy noises. This is a 2t minus 13. All right, and then we're going to add this 13 to both of their sides. End up with 2t is equal to 16. What's t? And divide by 2. And t is equal to 8. All right, we did it. Just put 8 in there, right? Notice I haven't written 8 yet. I hope you didn't. I hope you didn't fall for that trap. You can plug this in. Remember, these are congruent, so you can actually pick whichever one you want to substitute into. Excuse me. That was the heck? So I'd probably plug it into this one because it seems easier than this one. But it's 40 minus 13. So 5 times 8 minus 13. That's going to be equal to 40 minus 13 is 27. Woo! Oh, geez, I didn't put it over here. 108. All right. Easy peasy, right? Okay, let's come over here. All right, so they gave us this thing. This is an equilateral triangle, which means all the angles are how much? Well, if you add them all up, it's 180 degrees, but you end up with 3 congruent angles at 180 degrees. That means this one's 60. This is actually 60 degrees. So you can say z over 2 plus 14 is equal to 60 degrees. Do you guys know what to do with this fraction here? I wonder if you know what to do. But we know what to do with this 14, don't we? We're going to subtract it. You end up with z over 2 is equal to, oh, I'm getting behind my head. Let me move this up. Hope you got that. Z over 2 is equal to 46. Now, what do I do here? What does z divided by 2 mean? Or z over 2 means divided by, so it's the opposite of dividing by. Remember, you kind of want to make these ones. I want to make the coefficients into a 1. This is like 1 over 2. So how do you make a 1 over 2 into 1? You multiply it by 2. So it becomes like a 2 over 2, right? There's your 1. That's why if it was 2z, you divide by 2 because you want to make that kind of 1. Anyways, you got to do it to both sides. Why did I do this? Because it gets rid of this. Z is equal to 92. Seems good to me. It's not 92 degrees, I can tell you that. All right, look at this guy. Look at this crazy guy. What the? How are we going to do this? Good question. So I know this is 52. So obviously something's going on over here. I got an isosceles triangle. So that means my base angles are congruent. Just waiting for the lag to die down here. That means these angles are congruent. Okay. So if those angles are congruent, I can figure out this angle. Does that help? Maybe. Could help. But what I need to do is get over to this triangle. So the question is, what is this angle? That's a linear pair. What are linear pairs? What do they add up to? 180 degrees? Yeah. So this angle right here is going to be 180 minus 52 degrees. And that's going to equal to 128 degrees. Okay. Let's talk about what we just did there. Because this is an isosceles triangle, these two angles are congruent. That means this is 52 as well. Well, this is a straight angle or a linear pair. Linear pairs are supplements. So this angle plus this angle equals 180 degrees. Okay? So if this angle plus this angle equals 180 degrees, I can find this by subtracting 52 from 180. Whatever 180 minus 52 is going to be what this angle is right here. Okay? Hope that makes sense. Linear pairs are supplementary. I don't know. If I know one, I can find out the other by subtracting it from 180. Okay, let's move on. So this is 128. Okay, now I'm in the other triangle. That's a good sign. How do I get these angles? You know what? I'm messing up. There's an way better way to do this. But I'm not doing it. I should have done it. I see now that I should have done it. But I didn't do it. Oh well. Okay, so this is 128. And this is congruent? I'm just gonna do 3 arcs. So 128 plus x is equal to 180. I can't believe I didn't do the cool way. I'm so upset with myself. X plus x equals, I almost did the cool way even despite myself. X plus x plus 128 equals 180 degrees. I feel like since I already did it this way, I have to do it like this. It's just one more step. It's not that big of a deal. So I'm combining like terms. Just to kind of, if you're wondering what it was, this is like a remote, this isn't like a remote interior angle thing. Like this, x plus x is 52. If you didn't notice, you can kind of see the math here. I'm kind of doing the same thing twice. That's why it's the extra step. Well, whatever. Because watch this. Let's subtract the 128 from 180 degrees. You can see it right here anyways. Two x is equal to 52. What? Is that really 52? You 52 like the angle from before? Yeah, bro. Oh, that can't be a coincidence. It's not. I I should have used remote interior angles. Divide by 2, both sides. And x is actually equal to 26. Did you see the remote interior angles? That's a tricky little problem. Aren't triangles cool? How you can like travel around and like all these cool theorems. I think it's great. That's why it's my favorite stuff. That's a perfect example of why triangles are so awesome. Measurement of angle E. That's this angle down here. How am I going to get to this angle? What the? Well, I can tell you this. We're not making the same mistake. We're using remote interior angles. Can I, though? Because I need this angle. Okay. I'm going to go ahead and not do it. Okay. Because I'm going to end up with this like vertical angle stuff. I think that's probably better. So I'm going to do vertical angles to get there. So I'm going to figure out what this angle is, and that'll be the vertex angle of the other one. So, sometimes when you're doing these types of problems, you got to develop a strategy before you just start doing math. I'd recommend you do that. So what do we have to do? Okay, I have 2 congruent sides. That makes it an isosceles triangle. Isosceles triangles, they don't only have 2 congruent sides, they have 2 congruent angles. So if I can figure out this angle, then that's the vertical angle of this one. All 3 of these angles are the same because of vertical angles and because of isosceles triangles. And then these angles are going to be the same. Why? Because this is another little isosceles triangle over here. Okay, so I got to figure out the base angles of the first triangle. That'll be the vertex of the other one. And then figure out the base angles the second time. So I'm going to be doing some triangle angle theorem. Here we go. 94 degrees. So make this, I guess, x. I don't know. Make this x. So 94 degrees plus one base angle plus the other base angle. This is angle B. This is angle ACB. Is equal to 180 degrees. Okay, so that's going to be 94 plus 2x. I feel like there's a quicker way, but I just don't care anymore. I'm just going to do it this way. Then you subtract 94. Like at some point, the quicker way is just to get started, right? Boom, 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 boom. Get it out. Get it out. So that's going to be 2x is equal to 86. All right, easy. Divide by 2. Oh, I didn't write it in green. I hope you don't mind. X is going to end up being 43. So this is 43 degrees. And so is this. So if this is 43 degrees, what are these 2 base angles going to be? Let's call these y. Okay? I don't want to use the same variable. So, triangle angle theorem says 43 plus y equals 180 degrees. What am I doing? Why am I doing this? The question, or the answer is, I'm in this little tiny baby CDE triangle over here now. I know this angle is 43 degrees because vertical angle theorem. And it's the same thing I did over here. I had an x and an x. Now I'm just using y and y. Okay. So 43 plus 2y. Man, I love triangles. Subtract the 43. Why? Why? Divide by 2. Divide by 2. Great. 137 halves, guys. Okay, so y is 137 divided by 2. I'm going to go ahead and do a decimal here. That's going to be 68.5 degrees. Okay. Okay. All right, let's keep moving. Okay, so what is y? Y is way over here. Let's look at these triangles. We got some congruent sides here. So you got to stay in the triangle when you're doing what we're about to do. So how are we going to get over to this angle right here? Well, this angle's in an isosceles triangle, so it's going to be congruent to this angle. That's not the 40, though. So I got to do something over here. Here's how you're going to transfer over to this triangle. These angles are congruent to each other. So if I can figure out this angle, then I know this angle. So this 40 is the vertex angle of an isosceles triangle. This is also congruent to these other two. So we got a base angles, we got our vertex angle. Let's call this x, which means this is x and this is x. Okay. Triangle angle sum theorem says x plus 40 is equal to 180. Combine like terms. Subtract the 40. Hush. 2x is equal to 140. All right, divide by 2. X is 70. Okay. All right, so this is 70 degrees right here. This is 70, this is 70, and this is 70. So this is 70 degrees. So if this is 70, how am I going to get this guy over here? Oh, geez. There's a couple ways you could do it. You could write one cool equation, or you could figure out what 3y minus 5 is equal to. Or you could just set it all up right away, because I know that other base angle is 3y minus 5. So I'm going to do it the long I'm going to do it in one equation. So if this is 3y minus 5 and this is 3y minus 5 and this is 70, then that means that 3y minus 5 plus 3y minus 5 plus 70 is equal to 180. You understand why? This angle and this angle are the base angles of this isosceles triangle right here. So these are congruent, and this is 70. So you add 1, 2, 3 angles together. Let's do it with the purple. 1 angle, 2 angles. There's my base angles. Here's that vertex angle. Add them all together. It's going to be 180. Okay? Hope that makes sense. Combine your like terms, you end up with 6y's minus 10 plus 70 going to be plus 60. A little combining like terms, it ain't so bad. Subtract the 60. There you go. 6y is equal to 120. Divide by 6. And y is 20. Okay, so triangles get tricky. Main big things are isosceles triangles have two congruent sides, but they also have two congruent base angles. Okay. The other thing that we used a lot was that when you add all three angles on a triangle, you get 180 degrees. So you should be able to use both of those facts to set up an equation or something. A lot of times they're going to be making you do that. The other thing that you know is that equilateral triangles have 60-degree angles. So if you see an equilateral triangle, you just set that angle equal to 60. That's another equation you can set up to solve for a variable. Okay, let's do a sneak peek. Look ahead. So like this one right here, number 7. That's an equilateral triangle. 12y is equal to 60. Okay? Over here, number 8. That's an equilateral triangle. Those are congruent. Set them up equal to each other. Okay. I'm going to leave you there. I hope you all have an excellent day. And take care.